Okay, this is just another video to help students with series in Calculus 2. The first one is the natural log of k plus 3 over k plus 2. So we just applied the logarithm rule. This is the natural log of k plus 3 minus the natural log of k plus 2. Now that is a divergent because there's nothing on the bottom to make this converge. This just goes to infinity. Now we're going to simplify the partial sum. So first we'll put in n equals or k equals 1. So that's natural log of 4 minus natural log of 3. Then we'll put k equals 2. That's the natural log of 5 minus natural log of 4. Plus, when we put k equals 3, that's natural log of 6 minus natural log of 5. And then etc. to natural log of k plus 3 minus natural log of k plus 2. Now when we look at the series, the ln of 3 does not cancel out, so that stays there as the partial sum. And then we notice that the k plus 2 term is what's canceling out in our series. Therefore, what's left is the natural log of k plus 3. So our partial sum is the natural log of 3 plus the natural log of k plus 3. Okay, our next, we are going to look at n to the 4th over 1 plus n to the 5th squared. We're going to use the integral test on this one. Now there's three things that must be true for integral tests. One, it must be continuous. This one's continuous. It must be positive, clearly positive, everything's to even power. And decreasing. It is decreasing because the denominator will always be larger than the numerator. So now we're going to integrate this. We're going to take the limit as b approaches infinity, and we're integrating from 1 to b. Okay, of n to the 4th over 1 plus n to the 5th squared. So I'm going to use a u substitution for that. Let u equals 1 plus n to the 5th, du equals 5 n to the 4th dn. Then I'm going to substitute that in. I'll let you look carefully at that. I'm going to continue. The x of that would then be negative 1 over 5u from integrating from 1 to infinity. Once we resubstitute that back in, we have negative 1 over 5 times 1 plus n to the 5th squared from 1 to infinity. Now when we plug in our limits of integration, okay, we see that when you put infinity in there, okay, and then when you put 1 in there, of course, when you put infinity, that goes to 0, because 1 over infinity is 0. And we put 1 in there, you're going to get a negative 1/20th, but minus that gives you 1/20th. So since this does evaluate to a limit, and that is 1/20th, this one converges. Okay, our next one is n negative 1 to the nth times 4 to the nth over n factorial. So I'm going to use the ratio test on this one. So we've got 4 to the n plus 1 over n plus 1 factorial. I'm going to times that by n factorial over 4n. So I'm putting in plus 1 for each one of those, and then I'm dividing it by the original. So that's the same thing as multiplying by the reciprocal of that. So that will simplify then. We have 4 to the n plus 1, n times n factorial, divided by n plus 1 times n factorial. So n plus 1, you remember that a factorial again is like 5 times 4 times 3 times 1. For each time you do this, you go down by 1. So that's n plus 1 multiplied by n factorial. The n factorials do cross off, and we're left with 4 over n plus 1. Now remember, this still is as n approaches infinity, so I divide everything by n, so that's n over n, which is 1. On the bottom, 1 plus n, that goes to 0. And on top, 4 over n, that goes to 0. So we have 0 over 1, so this one evaluates to a 0, so it's absolutely convergent. Okay, so now we have another function, another series, negative 1 to the n plus 1 over the square root of n plus 1. Now I'm going to do a direct comparison. So a sub n equals 1 over square root of n plus 1. B sub n is 1 over the square root of n. So b sub n is larger because we don't have the plus 1 on the bottom. A smaller denominator means a larger series. So we look at 1 over the square root of n. That's 1 over n to the 1/2. That is a p series. So 1/2 is less than 1, so that is a divergent. So we know automatically this is not absolutely convergent. So then we're going to apply the alternating series test for this. Reminder that the divergence must equal 0 for alternating series, and the function or the series has to be decreasing. So we take the limit of 1 over n plus 1 as n approaches infinity. So I'm going to divide everything by the square root of n. Square root of n over n is 1. 1 over the square root of n would be 0 because n approaches infinity. And on top, 1 over the square root of n as n approaches infinity is also 0. So this is 0 over 1. So according to the divergence test, we do have equals 0. So that's good. Now we need to make sure our function is decreasing. So 1 over the square root of n plus 1. Your n is on the bottom, so as that approaches infinity, of course, that's going to be going smaller and smaller. So it is a decreasing series. So this series is conditionally convergent, but not absolutely convergent.